Welcome back, dear student friends. Today I am coming back with one more presentation on the internet based communication. So, in our previous presentation, we have seen how exactly a source and IP address, right? It gets connected through a set of routers to the destination. We have seen one example also with the help of a diagram where you had the source and network layer connected through a set of IP routers for the data packets from an IP address and communicating with IoT or machine to machine IoT application at the service layer. So that's what we have seen in our previous class. And whenever a data gets transmitted from one layer to another layer, right, what exactly are the different actions that are taking place, that also we have discussed in the previous presentation, right? So just a quick recall of that. Whenever the data is being transferred from one layer to another layer, right, so each layer performs the processing corresponding to the layer that is as per the header bit field, right, so which are received according to the protocol. Then whether the same thing is to be retained or some of the bytes or the bits are to be discarded, or you want to add some more thing when it goes to the higher level. So all those things are being considered at a particular level, right, or particular layer. Each layer receives the data from the previous layer, and after the required action, right, it either adds or subtracts the header words and creates the new stack specified for the next layer. And again, whether you are going from a lower layer to higher layer or the higher layer to lower layer, that decides what kind of actions are sequentially performed there. And ultimately the process continues till the data received at one particular port, right, is reached to its destination, right, step by step, right. So and again, in this particular case, you may have some of the encryptions being taken place in specific layers. So as I already told you, again I repeat, the actions that are taking place in a particular layer, that depends upon protocols of that particular layer, right, what exactly is supposed to happen as per the protocol, only those things will happen. So therefore the methodologies or the different actions taking place at the different layers in order to send the data or transport the data to a higher layer or a lower layer, right, they are unique for a particular layer, right. So now in some cases, right, you may have your FSC or that is called the frame sequence checking, right. So this is one of the error checking algorithm. You must have heard about the cyclic redundancy checking, that is the CRC, right. So to check whether a particular data byte is going in the proper way or not, some of the encryption algorithms may be included. So that will make you to add some additional bits or bytes in the entire packet. So these things do happen in different layers. So according to that, finally you will have to see to it that whatever the information you want to transfer from one layer, that is the source layer, to the destination layer happens. So in this case, we have earlier already studied about the physical layer and the data link layer communication protocols, right. So now we are studying about the internet layer, right. So we are studying about the internet based communication and what are the different protocols that are supposed to be followed in the internet layer. That is what we have to see here, right. So now basically we start from one unit here, that is called PDU, as all of you know, right. So that is called as the protocol data unit, right. What exactly is protocol data unit? So here if you look at this particular diagram, this will give you an idea about the communication between a source and destination in the internet layer, right. So as far as the internet based communication is concerned, the communication between a source and destination, and it also shows the PDU at different layers. So again I have mentioned PDU, again earlier also I had mentioned PDU means the maximum data bytes that can be processed in a specific layer, and you can see here it keeps changing depending upon the layer to layer protocol approach. Okay, so now when I speak about the the communication here, you please look here, we start from the physical layer, that is L1. Okay, then you go to the data stack from L2, then you see the PDU here, that is 1580 bytes. Then you go to L3, right, wherein you have the IP packets for the network. There the PDU gets changed. This is what I have told you earlier, depending upon the different layers, the total size of the packet, right, so that will change, right, because some additional fields will come into picture. For example, you can see here your L2 header, L3 header, L4 header, like that it keeps going, right. And finally, for the application and services, you have something called PDU equal to 2 to the power of 32 bytes per segment. And here one important point to be again recalled is that whenever you use the internet for the transmission of the data from one source to a destination, right, so the data which is sent in the form of the packets, right, so if you want to send a small information, right, the number of packets are going to be very less. If you want to send a big or huge information, the number of packets are going to be more or large, right. So you can consider it analogous to a train, right, wherein the entire train and the different wagons, right, so now if you want to have a large information to be sent, then definitely you will have a large packet wherein you will have different small wagons. All these data which are in the form of the wagons, they are included there, right. So if you want to send a small data or small amount of data, definitely the size of the train or the size of the packets, that also is going to be reduced, right. So that analogy you should always keep in mind. And whenever you transmit the data in the internet layers, right, anyway we will have to study about the TCP and IP protocols. I will come back to that, right. But one thing you should know here, that from source to destination, the data routing, you have got the routers, we have already spoken about the routers, right. The router will take care of routing the data information from the source to destination. And whenever the routing takes place, this is called as the hopping. It may go in any direction, right. It is not necessary that a confined path will be always followed for a source data to reach its destination, right. So again you take an example of sending an envelope or a letter from one particular place to another place, right. So you fix all the things, you put the address, you put the stamp, right. So then you put it in the post box, right. After having put it in the post box, suppose if it has to reach the destination, it is not necessary that it will always follow the same direction, right. So now something you have here, right. So there is one destination here. Now let us say that there are multiple paths for this source to reach to the destination. This is another path, right. Let us say that this is another path. So like this there may be so many paths, right. Now for your envelope to reach from source to destination, it is not necessary that it should always follow this path. It can be passed through this path, it can be passed through this path or this, right. And here when you have single envelope, the question is different, right. So when you have the multiple packets in the form of the data segment, all these packets need not pass through one particular path. The packets will have the different paths to reach its destination, and ultimately in the destination they will be reassembled as per the protocol. And according to that your internet protocol or your transmission control protocol works. Anyway, I will come to these points again later about all these things, right? So now we will have a quick what exactly we will have to study in our internet protocols, right? So now if you look at this particular diagram, basically this diagram, as I've already told you, tells you about how exactly the communication takes place between a source and the destination. And having said that, I have also spoken about something called PDU, protocol data unit, right? This is the maximum data bytes that can be processed in a specific layer, right? So now if you look at this diagram, okay, a data segment is accepted from layer L7 for the transportation layer of our transmission control protocol. So this TCP is the protocol that we follow in our internet terminologies or internet communication. Please note that it is transmission control protocol. So what exactly is this, right? So what are its features, that we will definitely see as and we come later, right? So now a maximum 2 to the power of 32 bytes, okay, PDU. So that is the number of bytes that you can see in a typical application and service layer, right, as far as the internet protocol is concerned, right? So now a data segment is accepted from the layer 7 for the transportation layer, then the L4. So you know this is the layer L4, okay, this is the layer L4, right? So this L4 generates a TCP stream, the transmission control protocol stream. What exactly happens in this case is the stream packetizes at the internet layer L3. So alternatively, a datagram, we have already spoken about what exactly is a datagram earlier, right? So it is with a maximum of 2 to the power of 16. You can see here PDU in this case from L4 to L3 is 2 to the power of 16 is accepted, and the L4 generates the datagram. The stream packetizes at the layer L3 into again the packets. Then the packets sent from L3 has a maximum size of 2 to the power of 16 bytes, including the header of L3, right? So then the datagram sent from L3 has maximum size of 2 to the power of 16. Then you can see here it keeps coming to the lower and lower layer, right? So this is what is going to happen whenever you see a typical communication between the source and destination with the values of the PDU, right? So how exactly the total data that you are supposed to send from one layer to another layer, it keeps changing in terms of its totality, that is in terms of the header values or in terms of your CRC or FRC bits or bytes which are going to be added, right, or which are going to be subtracted or something like that, right? So now this is the basic diagram which is in connection with what I had told you in the previous presentation. Whenever the data is received at one layer from its previous layer, what are the actions that are going to be performed, that is shown here with the help of a typical diagram which represents the communication between the source and destination, right? So you start from somewhere 2 to the power of 32 bytes for the application layer, then it comes somewhere around 2 to the power of 16, then it comes to a data link layer bytes of 1580. This is a typical case, right? So now you can understand how exactly these values keep changing whenever you have the data flow from the upper layer to lower layer, and from the lower layer to upper layer also a similar task takes place, right, in the reverse order. That also I have told you, each layer receives the data from the previous layer, and after the required action it subtracts or adds the header words, creates a new stack specified for the next higher layer, and this process continues until you reach the destination or until your data reaches the destination, right. So this is how the things take place in our internet scenario or the communication scenario, as long as the internet layer is concerned. And maybe when it comes to the data link layer here, right, so because physical layer generally, we cannot have its access to the internet connectivity. Whatever the internet connectivity we will have, it is generally confined to a data link layer or the network layer or even your application layer, right. So only the higher layers, they make use of the internet protocols. The physical layer need not make use of any internet protocol. Okay, so now when you start sending the data, right, so first thing we have to see here, whenever the internet layer is being used for the transmission of the data from one layer to another layer, what are the protocols that it uses. So I have already spoken about these things, that is internet layer protocol IPv4 as well as IPv6, right, internet protocol version 4 and internet protocol version 6. So now what exactly is specified in this internet protocol version 4 and internet protocol version 6, which I had also mentioned that it is the latest version in the internet protocol, that we have to see. But before that, we have to see one more thing, that we have something called as MAC, right. These words you should be able to remember and recall. Media access control, right. So we have something called as ARP. So this ARP stands for address resolution protocol. Okay, so and you have also something called as NDP. You have something called as network discovery protocol. So these are all the protocols, or these are the protocols as long as the data link layer is concerned. So these are the different protocols that your data link layer uses in its each sublayers. The data link layer uses these protocols in its sublayers, right. Ethernet, we have already spoken about this. Ethernet, this is one protocol for logical link layer on a LAN, right. So Ethernet protocol. So this media access control or address resolution protocol or the network discovery protocol, these are all the different protocols that your subset of the data link layer that it uses, right. So now when I have spoken about these things, the MAC or ARC or NDP, we will generally come across in our internet terminologies, right. Whenever the data is transmitted from a higher layer to lower layer, so your internet protocols have their own certain roles to be played as long as these sublayer protocols are concerned. So these things also I will take up when I start discussing about the protocols which you use in our internet terminologies, that is internet protocol version 4 and internet protocol version 6. Okay, so this is one diagram which I wanted to convey, as long as the communication between the source and destination happens or takes place with the values of the protocol data unit, which is the maximum data byte which can be processed in a specific layer at different layers, right. So with these things, now let us move on to the exact protocols, right? The exact protocols which your internet communication or the internet layer uses in order to make sure that the data is transmitted from one layer to another layer. Okay, so now as I have already told you, this is internet protocol version 4, and let's start the version 4 now, right? So again, no need to mention that these are specifically designed for layer. Okay, now what exactly the internet layer does is it receives and forwards the data to the next stage, right? This is one of the layers in your total the communication scenario, right? And why we are particular about this internet layer is we are studying about the internet of things. So lot many communications from your physical sensors or your IoT machine to machine communication, right? They are required to be processed at the application layer. You please recall the example of your smart sensors, or smart umbrella, or the street light control, or something like that, right? So invariably we will have to make use of the internet layer in order to have our IoT applications realized, right? So for that particular purpose, we need to understand what are the different protocols that we use in our internet layer, right? So internet layer receives and forwards the data to the next stage and uses the version IP4, or it also uses the version IPv6, and you have got one more thing, right? Routing protocol for low power lossy network, LNN, right? So this is another protocol, and you have got one more protocol in your internet layers that is called as 6LOWPAN, and this is specifically for your IoT and machine to machine communication, right? So 6 low power wireless personal area network, this is another protocol which we generally come across in our IoT scenario, right? So now we will see about these things. First we will start from your version 4 IoT v4 protocol. IoT v4 protocol headers and data stack. We will see what exactly we can find in our version 4 as long as the communication protocols are concerned, right? And you can see here the TCP header plus data consists of data from the transportation layer, from the inter layer. Each packet consists of 5 words, basic IP header field of 60 bits and extended header up to n words. So this you will not be able to understand for the time being. So I will show you what exactly is the format, okay, that we follow in our IPv4 protocol. So once I show you the format diagram, so you should be able to understand what exactly we mean by this, right? And here one word means 32 bits and n is the total number of header words added at a IP layer. Now you please, with these things, without much of the understanding what we see here, please look at this diagram. So probably this diagram should be able to tell you how exactly the data stack received or transmitted at or to a network layer and IP packet consists of what, right? What exactly we mean by the header field 160 bytes, 160 bits, then extended header field up to n, just now we have spoken about. So now please have a look at this particular diagram or this figure, wherein you can see here 0 to 3 there is one set, then 4 to 7 there is another set, then 8 to 15 you have got another set, 16 to 31 another set, like that you have the 2 to 160. This is what I just meant here. From internet layer, each packet consists of 5 words, basic IP header fields of 160 bits and extended header to n words, right? So now you can see here these are the 5 words, 1 2 3 4 5. So this whole thing stands for the header, okay? So again, what exactly is there in this header field? There are, you can see so many things, right? So IP packet length words, you have, you know, service type and precedence, right? Service type and precedence, IP version, fragment offset, flags, first byte sequence number in the stream, checksum, type of protocol, time to live. All these parameters are not required for us for the time being in order to understand the protocols, but wherever we find their application, wherever we find their use, we will see. But what is important for us in this case is the source IP address and the destination IP address, right? So sometimes you have the extended header also, depending upon the need. Where exactly we need that we will see. Okay, so now let us quickly to these things, what exactly these things mean. Okay, first, as I have already told you, the IP header consists of 5 words that I have already told you, and you can see in this diagram also 5 words, right? The header extends by using option words and padding word depending upon the requirement. Okay, so now packet maximum means 2 to the power of 16. I will come to this particular point. Let us not go into the details right now, right? So now here I will show you. Yeah, so now if you look at this particular diagram, okay, if you look at this diagram, okay, I will make it a little small. Okay, so what exactly the fields are, right? So one second. Yeah, okay, so B31 to B16, right? So where exactly you find that 31 to 16? Yeah, you start from here, right? So this indicates the IP packet length in the length in words, right? So you know, from one layer to another layer, whenever you want to transmit the data, right? So you have already seen that some of the header words, right, some of the, you know, checksum and other fields are going to be added, right? So accordingly, in this protocol version v4, right, so what exactly the bits 31 to 16 show is the length in the words, right? Then the service type and precedence, this is the second one. Let us not go into these details now, but I will only show you what exactly are the words, the service type and the precedence. Then B0, sorry, B3 to B0, the version, right? So this shows about the version, that is 0100 for version 4. Like that, you have something called as the fragment offset, specifies which data stack length word consists of which fragment and in the data stack of the transport layer. So this is not you know, required for us to understand what exactly are these things, right? Then you have something called as the flags, right? You must be knowing the meanings of the flags, right? So then you have bit 46 to 32, right? That is going to give you the byte sequence number in the packet of the TCP stream. Then you have got bit 95 to 80, that is called as the checksum. 95 to 80, that is the checksum, right? And bit 79 to 72, the type of the protocol. There are different other types of the protocols which you know, this IPv4 supports, right? The type of the protocols. Then you have got something called as B71 to B64, which is called as the time to live, right? So time to live basically means the number hops try to reach the destination, right? I have already told you in the earlier presentation that you have the data packets like this, right? And you have got the destination here. So in how many hops these data packets are able to reach the destination, so that is also going to be specified here, right? So these things are not you know, really necessary for us to you know, check or understand. Okay. Okay, so B71 to B64, the time to live. Then we go to the next one, B1 127 to 96. So this is important for us. So this is where we need to apply our minds. Source IP address and the destination IP address. These two things are very essential for us to understand the protocols of internet version v4, right? So what I mean to say here is, this case, whatever we have here, right, that goes with the network terminologies as available to your internet protocols. But what we are interested in is these two, that is the source IP address and the destination IP address. And please remember that in your version v4 you have got a 32 bits for the source IP address, and again one more 32 bits for the destination IP address, source IP address and the destination IP address. Okay.
Here now, right? So basically what we have seen in this today's presentation is that how you have the communication between the source and destination takes place in our internet layer. Okay, so what do you mean by the different lengths of your protocol data unit at different layers, right? How the protocol data unit PDU width keeps changing from layer to layer whenever the communication takes place from a lower layer to higher layer or higher layer to lower layer. Then one of the protocols that we use in our internet communication, that is version v4, right? So as long as the version v4 is concerned, we have seen the diagram, right? The data packet from a transportation layer, right? So how the data packets move from the transportation layer and what are the different fields that we have in the data packets, right from your 0 to say 64, which deal with your the length of the packet, service type, precedence, then version of the IP, fragmentations, flags, right? Then the sequence, right? Checksum, the type of protocol, the time to live and other things. And from 127 to 96 and 159 to 128, that is the source IP address and the destination IP address. So this in general you can consider as the structure or the nature of the header, okay, the nature of the header of the data packets or the data stack from the transport layer. So basically we deal the data transfer in the transportation layer as far as the version v4 is concerned, right? So similarly we will see one more version, that is